Hey folks, how's everybody doing today? Happy Tuesday. I'll give that a pause here. Alrighty. So we are moving on to chapter 2 here in our Zybook. Again, that's our online interactive textbook. It looks like only 13 of you folks have actually gotten it so far. Let me know if you're having trouble or something. I mean, technically you don't have to get it, but remember it is 10% of your score for actually like reading the textbook and doing the interactive things. So like that's your incentive to actually go in and read the book. And for quizzes, I totally forgot to post the quiz for chapter 1. So I'll post that today. Apologies for that. Usually I'll post them after we finish the chapter on Thursdays, but that just slipped my mind. So let me leave myself a little note here. Post Python quiz chapter 1. There we go. And thanks to the lovely notepad here, it will remind me. And even if I try and shut my computer down, it won't shut down because Notepad is open. I love that. All right. So anyway, variables and expressions, chapter 2 today. So we'll do that today and Thursday. And then next Monday in lab, we'll do a lab for the chapter 2 stuff. So if you missed lab yesterday, no big deal. Or again, if you want to do the remote, that's perfectly fine. I'm not opposed to that if you're not comfortable coming to campus. It's okay. But just let me know if you have any issues with it. I'm not typically going to talk about them on Thursdays. I wanted to talk about Lab 0 and show you so at least you had like a recording to go off of. But usually after that, the labs will show up in Canvas here in the assignment section on Mondays, and then you'll have, ideally you get it done before you walk out of lab that day, but if you need a little extra time, it's not due until the next week, 11:59 p.m. So if you had any last minute questions and you wanted to wait until the next lab when you saw me in person, great. I can answer those questions there. But try not to get behind, because then you're just always going to be playing catch up, and that's not great. So we'll take a look at that, the labs. If you have any questions, let me know. Again, I'm happy to walk you through those. That's why we have that in-person time, so I can actually, sit next to you or look over your shoulder and see your code and see what's going on. Our screen sharing tools are pretty good nowadays, but it's a little quicker if we're just all in the same room. And then if you have questions or you want to work together with a partner, you're more than welcome on the labs to work together on them. Right? The idea is this is our chance to exercise and try and practice these things before we get our projects. And the projects will be individual projects. Okay? All right, so let me fire up PyCharm here. PyCharm. I do have the latest version now. So excited. It's got a lot prettier startup screen here, which is nice. Eventually it'll start. And I got my cold brew here, so I am pretty wired, which is good. So if I'm going too fast, just feel free to shout, and I'd be happy to slow down or cover something again. Come on, PyCharm. There it goes. Maybe. I was thinking about loading. Next time I'll have to start that beforehand. Hey, good afternoon, Trumpet Man. Thanks for coming along. Goodness. PyCharm is a hog right now. Everything's going slow. I've got a storm blowing through right now, too. I can hear the rain. It's nice. Ah, some big rain. What What is my computer doing? Why is it so slow? Alright, that was just my little test project. I'm going to start up a new project here for Chapter 2. I can put all the examples in as we go. Again, that'll be available in the course repository page. Wow. I can just hear it hitting the window. It's like super loud. We'll do Chapter 2. Again, usually you want to use previously configured interpreter. So there's advantages of using a virtual environment and setting up a new one every time. Until we get to actually importing modules, it's not going to matter at all for us. So using the built-in one is just going to be fastest. If you make a virtual environment, it essentially copies all of Python into a little folder for you, so you have a little standalone version of it. So it's not a big deal here. So again, we'll just use our previously configured interpreter, our Python 3.9, and we should be good to go. And I'm going to open it in this window. I don't need the old test project around. Actually, I want to get rid of that. So I'm going to check my GitHub repository here. And I can go delete that test stuff. Let's see. I'll just launch it from GitHub here in a second. That is so slow. And Task Manager is slow. It's just PyCharm being a hog. Sorry, my sugar's a little high right now. There we go. Yeah, it's just PyCharm on OBS. Yeah, I mean, OBS always uses a steady amount, but it's not crazy intensive. All right, I'll just call that good. So we pull up the 1501 repository. Maybe. 501. Here we go. Remember, again, Git is just watching this folder for changes. So it's looking for anything new, anything changed, anything deleted, and then it allows us to take those commits, which is a snapshot of that point in time. So I've got this old test project. I was just wanting to make sure it worked. I see my Chapter 2 project, which is good. So I'm just going to show it in Explorer. I'm going to go get rid of that test folder because I don't want it. So you can put multiple projects in a repository. There's nothing wrong with doing it that way, but when we use the GitHub Classroom repositories and we get that feedback pull request, it's going to be a lot cleaner and easier for me to find things if we use one repository per assignment. So every lab will have a new repository, every project will have a new repository, so we can just put all of our stuff right into that repository folder, and then it'll keep each one separate. So I'm going to have one with all the different projects from the examples we do. But when you do your assignments and labs, you'll have one repository, one folder for each assignment. Okay? All right, so test is gone. It should disappear out of here. There we go. And I'm just going to put my commit summary. We'll just say Chapter 2 started. I get all these idea files. That's fine. Just leave them alone. That's so PyCharm knows it's a project. And I'll commit and push. So committing takes the snapshot locally. And then once I push, it's pushing all of my changes local out to that cloud github.com repository. So I'll push that. So it's this idea of push and pull. So if changes happen in the cloud, you need to pull them down locally, or if you make changes locally, you have to push them out to the cloud, or that central repository. Technically, it doesn't have to be out in the cloud. Depending on which Git tool you use, you can have one internal on your network if you want. Some people like that, and depending on what sort of rules you have around storing your code, whether or not you can store it on other people's servers or it has to be internal on your network, that's up to you, or up to your organization. So. All right, so I'm just going to leave my Git repository open here. I'm going to come back to PyCharm, and here's the little starter main here. So we'll just print Happy Tuesday, and let me zoom that in a little bit for you, and make sure this runs. Again, you can right-click Run, you can click the Run button up here, you can go to the Run menu up here, any different way you want to run, perfectly fine. I'm fond of right-click Run, Control-Shift-F10. I think is the shortcut for that. Oh my goodness. Run. So if you like keyboard shortcuts, great. You can use your keyboard shortcuts. I get Happy Tuesday. All right. So we're in good shape. The program runs, and now we can start actually looking at some fun examples here. All right, so remember we looked a little bit at how we can set values for things. Now, whatever you want to call that value, this is our variable name here. So this was like our hours worked, right? This is our variable name. And the reason why it's a variable name is because it's the name of whatever we're going to call the value that we're storing. And the value that we're storing can vary. It can change because, I mean, if I say it equals 42, then it's not going to change much. But if it was based off of some input, what the user is typing in, I don't know what they're going to type in. Maybe they say they worked 100 hours that week. Or maybe it was a really bad week. Right? Or maybe they said they worked 0. They had the vacation time or something. So the value of it can vary, and this is our name for it. So everywhere else in our code, we get to refer to the current value by name of hours worked. And we're not in math land anymore, so we don't do equations on the left. So the only thing on the left is going to be what we're assigning to. Remember, so it's not an equals operator, this is an assignment operator. It's going to take whatever's here on the right and assign it to the variable on the left. So we can't say like total pay times 2, I don't know, equals something. Like you can't do arithmetic on the left. We can say total pay equals hours worked times, oh, now we need a pay rate, right? So pay rate, and that should probably be hourly pay rate. So we can do the arithmetic here on the right and assign to the value on the left. Now right now I'm getting this nice red line that says unresolved reference pay rate. Python says, I don't know what an hourly pay rate is. You never told me what that is. So I need to make sure that that gets assigned, right? Hourly pay rate, I don't know, 15 bucks an hour. Sure. And we'll just set that back to 40, right? And then if I want to print, right, you can just comma separate the values. So again, total or weekly pay this week. And we just comma separate. I can throw total pay in here. And Python's going to be happy. It'll just stick those together. It'll put actually a space in between them because it's nice and helpful. Right, so we get whatever 40 times 15 is. That looks like it checked out. Okay, so we get our total pay. Again, this is all stuff we've done previously. But you need to make sure all the arithmetic is on the right. The values are on the left. All right, let's see. I think we're good there. Kind of following along the textbook, making sure we're not doing anything new here. Yep, so what happens behind the scenes, which is really cool, is Python has to go ask your operating system for memory to store these things. And all these values are stored at some location in memory. So all these are actually, they're objects. Everything in Python is an object that we store, and objects all have a couple properties. So everything has the value. In this case, the value is 15. If we had some sort of string, we said like name equals Eric, the value of that is the string Eric, wherever we're putting that out in memory. Now Python also tracks the type that this is. So this type here is an integer, because it's storing an integer value. This type here is a string, it's storing a string value. And then you also get this cool identity, which is the unique identifier of an object, which is kind of fun. So you can check some cool things here. So if we wanted to say print and use the type, and we say, hey, what type do I want to check? I want to check what is total pay. So I'm just going to grab this here and put that in a string, total pay, and then I'll just comma separate to get the type of that total pay. So we can ask Python, hey, what type do you think this is? What type are you storing for this? And it's a type of int, the class int, so integer, right? It's a whole number. Now, Python's smart enough, and if any of these is a decimal, right, we're going to have floating point numbers. Because if you're doing arithmetic with numbers with decimals, your result will give you a number with decimals. So we have a floating point number, right? Even though the result is actually a whole number, right? 620, it worked out evenly. It might not, so it's still keeping the decimal place. So we can see the type. We can get the ID. We're going to get the ID of total pay. And the value, right, is just the variable itself. That is what the value is. So like, value is the default, right? If you just say total, if you say the variable, you're going to get the value back out. Okay, so you can check the value, the type and the ID of each of these, which is kind of fun. So Python is tracking all this internally. I have no idea what this number is, but this is the internal number check, or number that Python has. So that's how it's tracking, knows where it is here. Now, a couple rules for these variable names here. Right? You want to be long and descriptive. Don't use abbreviations unless it's like a really, really well-known abbreviation. And even then, it's not hard to type it out. And then you don't even have to type it again. If you just start typing like our, give it a couple letters, PyCharm or any good IDE is going to suggest, hey, do you mean this variable, this variable? I can just arrow up, down, whichever I want to do. And then tab will finish typing it for me. So don't tell me that long variable names make it harder to type them, because they don't. You don't even have to type all of them. Right? And again, usually we use underscores, this snake casing, and we separate every word with an underscore to make it easy to see. Other languages, C++, I think most other languages are probably use camel casing, so we'd say hourly pay rate, where every next word gets a capital letter. Kind of looks like a camel's humps. We call that camel casing. And Python's fine with that, but it's not the usual convention. So usually you'll see code with underscores, but if you see this camel case, it doesn't matter, right? Hourly pay rate, we can still say 15.5 or something. Python doesn't care. Either one is fine, because this is just what we're referring to it in our code. But we just want to follow, this is called like a style convention, and to make sure we're keeping our style the right way. And you can use letters, you can use underscores, you can use numbers, but you can't start with a number. So I could say name1 equals something. Sure, but I can't say one name equals something. You have to start with a letter or the underscore. And then there's a bunch of reserved words that have special meanings in Python that you can't name your variable with. And there's a whole list in the book. Don't worry about trying to memorize it at all. If you like scientific notation, you can actually use scientific notation when assigning floating point numbers. I personally am not a big fan of it, but if you're working with really small things, sure, that's fine. You can use your scientific notation. You just throw an E in there, and then you're fine. Man, what is... I gotta Google this now. Speed of light. So approximately, what is that? 300,000 meters per second? No, 300 million meters per second. All right, so if we said, speed of light approximate, we could say 3, and then what is it? E to the, oh my goodness. I'm so bad at scientific notation. So that if it's 300 million, we're going to have 8 zeros, right? So that's 3E8. That sound right? All right, let's see what it prints out. Approximate. Oh, did I spell it wrong? Approximate. Thinks I have a typo. Rename. Approximate. Is that? I don't know. I spelled it wrong. I'm sorry. My apologies. Is it 2 P's? 2 P's. All right, let's see if it prints out nicely for us. There we go. Does that look right? So there's the hundreds. There's the thousands. That's 300 million. Right? Meters per second. That look okay for a speed of light? All you folks who actually took physics or other sorts of things, correct me. Cool. Now, Python does have a limit to how large of a number you can store. Right? So the integer value can only store so large of a number. A floating point number can only store so large of a number. So it looks like the largest one you can store, oh, why is that even a value? 1.8 times 10 to the 308th power? Sure, that is something somewhere. Let's see. So dealing with floating point numbers with tons and tons of decimal places is kind of obnoxious. So there's a really cool library called math, right? So if we want to import math, we can use all the cool things in the math library. One of the cool things in the math library is pi. So if we print out math pi, we're going to get a bunch of decimal places. 3.141592653589799. 3? Did that get rounded? It might have gotten rounded. I forget. It's been a long time since I memorized the digits of pi. But if you don't want that many digits of pi, there's a really handy way of formatting the number of decimal places. Now, to do it, it's really funny. And don't bother memorizing it. This is called a string formatter. So you give it a set of curly braces inside of quotes. And then you say, how many decimal places do you want? So like, hey, if I only want 5 decimal places, I say 0.5. I want 5 decimal places. And then I put an F in here to say, hey, this is a floating point number. Give me 5, rounded to 5 decimal places, a floating point number. So I give it a string, and then I say format, and I say math.py. So what it does, this format here, is going to take whatever value is here, and it's going to stick it inside of those curly braces. So we could say pi to 5 decimal places. And then once it finds these curly braces, it will substitute whatever was put inside of the format here. So it's going to take this and plug it in here and do the rounding to 5 decimal places for us, which is really handy. This is a format string. Oh my goodness. 0.5F. Nope. Oh, I missed a colon. Sorry, I need a colon here. Colon 0.5F. There we go. 3.14159. There we go. Pi to 5 digits. 5 decimal places. Okay? You know, I read somewhere, I forget where it was, like, you only need pi, was it like to, I think it was only 5 decimal places to, like, land on the moon properly or something silly. That was a really interesting article. Hang on, what was it? So, pi, land on the moon. Something like that. That's what it was? Yeah, from NASA. Oh goodness, that's way too many. Oh, okay. So that's a couple more than I thought. Wow. So 15 decimal places. Okay. 15 decimal places. Oh goodness. All right. So 15 is a lot for the Voyager mission. 12.5 billion miles away. That's cool. You're only off by 1.5 inches, 25 billion miles away with that. Nice. That's pretty cool. All right, anyway, totally random thought there. We can round it off if we need to. Okay, a helpful arithmetic operator here. Say print, I don't know, like 3 to the 5th power is, that notation is double multiplication, star star. Is the exponent operator. So 3 star star 5 is 3 to the 5th, which is pretty cool, right? 927, really big, right? 243, that looks right. Okay, so this is the exponential operator. That's the exponential operator. Okay, that's x to the y. Okay, that was pretty straightforward. Another really cool operator you might not be familiar with, because I don't think we ever really use it in math, is called modulus. And modulus is one of my favorite operators. So if we say, let's do 13 modulus 5 equals. Let's try it. So 13 modulus 5. What modulus does is it gives you the integer remainder of the division. So it's like division. This is modulus. Like division, but gives the integer result, gives the integer remainder. Okay, so 13 divided by 5 you give us a remainder of 3. So it's not the actual division here. This is modulus. Modulus is a fantastic operator, and its order of operations or order of precedence is the same as multiplication and division. Did I get into that with you folks, how order of operations works and why we're so terrible at it and we teach it really badly in school? I don't know why. I feel like we could do better teaching it in school, but I don't know, maybe some of my math teacher friends might disagree with me. Nathaniel, I'm not sure what you mean, the modulo or remainder? I don't actually know what you mean by modulo. It's the integer remainder. So for order of operations, you get all these silly things like, what is, I think this was the one I saw most recently, 10 minus 10 times 10 plus 10 or something like that. Right? And they're like, hey, only so many people will actually get this correct. And you have to remember your order of operations, right? So the multiplication happens first. Right? That one's not so bad. But then you get into ones like, hey, let's do, how about 10 divided by 5 times 10 plus 10 here. And this one here, people tend to argue, and I still don't understand why, but maybe I do. So when we learn order of operations, right, we learn this PEMDAS, or please excuse my dear Aunt Sally, right? You get your parentheses, exponents, multiplication, division, addition, subtraction. Here, subtraction. Does that look right? Now, you know, think back to your math classes here, and if we were to say 10 minus 5 plus 10. Okay, what does this equal? Now, no one is going to tell me that you do 5 plus 10 first, so that's 15. 10 minus 15 is negative 5. No one says that, right? Because we understand that addition and subtraction have the same order of precedence, so we do them left to right. We would do 10 minus 5 is 5, plus 10 is 15. The exact same thing works with multiplication and division, and I don't know why people don't understand that, right? So just because you say multiplication first doesn't mean you do the multiplication first. They have the same level of precedence, so we do them from left to right. So we get 10 divided by 5 is 2, times 10 is 20. Not 10 divided by 5 times 10 is 50, 10 divided by 50. Right? Just because you say multiplication first doesn't mean you do it first. Just like in addition and subtraction. Just because you say it first doesn't mean you do addition first. Right? You read it left to right with the different levels of precedence. Okay? Sorry. That always seems to bother me when people get that wrong. And again, if you want to force order of operations, use parentheses. If you want the multiplication to happen first, use the parentheses. Perfectly fine. No big deal there. Right? That's why we have parentheses. Excuse me. Right, a couple cool shortcuts here. So if we were to say, let's do our pay rate, hourly pay rate. If we wanted to increase our hourly pay rate, say, hey, we just got a raise. Hourly pay rate plus 1. Here, right, this says, hey, take the current value of hourly pay rate, add 1 to it. The thing on the right happens first, and then we assign to the value on the left. Well, we're assigning it back on top of, so we're overwriting the value of hourly pay rate. We're changing the value of hourly pay rate to whatever it used to be plus 1. Right, so if we print hourly pay rate, and then we add 1 to it, and then we print it again, it should go up by 1. Right, it was 15.5, now it's 16.5. Now, it turns out, you know, like all good programmers, we're lazy. So there's shortcuts. There's ways to do this that are more efficient. That means less typing. So if I want to give you a raise, I can say hourly pay rate plus equals 1. This is a combined assignment operator. It does the operation first and then assigns back to the thing on the left. So it does the exact same thing as above, but it's less typing. And, you know, generally we like less typing, right? If you could do something more efficiently, that's how we're going to do it. Now, and it's still readable. You still understand what it does. We're not saying less typing for, you know, sacrificing readability. This is just less typing because it's quicker to type. It's a well-known shortcut here. Right, so look, we gave you another raise here. So you can do plus equals, you can do minus equals, times equals, divide equals, modulus equals. Right? You can use any of those operators with the combined assignment operator. Okay? Now, another cool thing you can do in Python, if you want to have some really big numeric values, so I don't know, here's a billion. 1 billion, right? 1 billion equals, there's 1,000, there's 1,000,000, there's 1 billion, and sometimes it's hard to see all these numbers, like see the groupings, right? Now, you can't put commas in. Python's not cool with commas. Oh, and look at that, I even had one too many. I can't do this. Python's going to get upset with me. What you can do instead is you can use an underscore in your values for your groupings. You can use an underscore for digit groupings. Now, Python won't care. It really just ignores the underscore, right? Perfectly fine with it. So it was warning me before. So these little like yellow lines here are warnings. It says, hey, there's no new line at the end of the file. That's just a style convention. So you can ignore them, or usually I get upset when there's yellow lines, so I don't worry about it. It's not a block comment. Does it think I'm too long? I don't know. Maybe it should be a space. There. Okay, now it just doesn't think I spelled PEMDAS right. That's fine. So you can use these underscores for your digit groupings, just a little, make it easier to see what your values are there. It's really cool. Another cool shortcut, another operation here, if you want only integer values from your division, I can say 5 by 2 as an integer result equals, I'm going to say 5 integer division 2. So double slashes here is integer division. And that means don't give me a decimal answer. Only give me the whole number. So how many whole 2's can I divide 5 by? Right, so that's 2. Right? 2, and then I can even say remainder. And then to get the remainder, that'd be 5 modulus 2. Right, because modulus gives me the remainder. So 5 divided by 2 is 2 remainder 1. Right, if I only have a single division, right, I'm going to get a floating point result. I get the real 2.5. That's not what I want. Right? Oops. So the double slash is for integer division. It's a nice little shortcut here if you want integer division. All right, cool. You guys are doing great. We're flying along here. All right, now a cool thing, when you store text, right, behind the scenes, what actually happens is each individual character is stored as a numeric value, or it's Unicode value. So there's a really cool table if you look up the Unicode character values. Character values. It'd help if I could type right. Values. Sure. UnicodeTable.com. Look at that. Look at that. They show us what their values are. So a capital A here is 65. So the numeric value 65 represents the capital A when we store it as text. So if I wanted to print just a capital A here, all I'm going to get is capital A. But if I want to get its numeric value, right, I have a cool operation. I can print, it's called the ordinal value, ord, of A. How about we do this? A, ordinal A, there. I think that ought to work. Give that a run. So see, A is 65. Look at that, it worked real nice. So when we store strings, we're actually storing numeric values for all of the letters. Because remember, we can store numeric values very easily, because everything has to be stored eventually in binary behind the scenes. So we can store the individual characters one at a time. It's a little bit of a process, but that's okay. And then when we're printing strings, there's a couple special characters that are really hard to print, right? So if I wanted to print, say, a tab character, so tab here is \t. So / here is called the escape character. That's our / to say, hey, the thing that comes next is special. That's my escape character. That'll print a tab there. You can do those. And then if you want a new line, that's \n for new line. So new line will go down to the next line. Usually when we print, we get new lines automatically. This will do an extra one. A new line, and then maybe we'll say, how about a quote? Or a single quote, right? / single quote. So if you want to print a single quote mark or single apostrophe inside when you're using single apostrophes as your quotes here, you have to do it that way. And we'll see it's going to put it down a line. It's pretty cool. Right, so we get our tab. That's the tab character in here. We get the new line, put it down a line, and then we get our single quote. We just get the single quote mark. Okay, so those are some shortcuts. If you want to put them into your string values, you have to use those / or escape sequences, those escape characters. The other thing you can do is you can declare something as a raw string, and raw strings are fun. So if it's a raw string, you just put R in front of it. And what that means is it wants to not escape anything. Take the actual value here. Let's give that a try. Right, so we get the actual value of it here. It doesn't do any of the escaping. We're saying, hey, take the raw value. Just ignore it. Don't try and translate anything. Don't try and convert anything here. Just take what's in here, put it in, and it's perfectly fine. So raw strings are fun. You can do a lot of things with them there. So we looked at ordinal values of characters. You can do the other thing. You can go the other way. Right? So if I say, hey, I want to check, say, let's do, I think it's 70 as a character. And I'll put char, CHR for character, of 70. And I'll run that. Oh, F. Oh, I need 69. Sorry. 69 is an E. And then let's do, so an R, it must be probably, what, 82 or something? I don't know. And then an I is E-F-G-H-I. 4 more, so that's got to be 73. 73, and then a C is going to be 67. So if I wanted to spell my name here, again, I don't think I'm actually getting R at 82. I don't remember what it is here. I'd have to look it up. I got it. It was 82. E-R-I-C. So I could spell my name using the numeric values, turning them into characters. These are the Unicode values. So 69, 82, 73, 67. That's how you spell Eric. Pretty cool, right? Awesome. Cool. So that's actually most of our content here for Chapter 2. You folks did awesome. We are cruising through it. I know it's all new, so it's going to take some practice. There's lots of practice there in the Zybook, right? And you get points just for doing it. Like the regular exercises and the Zylabs. Right? The Zylabs are like their bigger practice. You have to make it spit out exactly what it wants. Now, it is a little bit annoying because it looks like space for space for space has to match. But that's a good level of attention of detail that you want to practice getting into the habit of. That if it asks you to print it out like this, you print it exactly like that. Now, for some things it's not super important, but for other things it's really important that it actually matches letter for letter for letter. All right, I think that's all I have for today, actually. So on Thursday we'll pick it back up with some more practice, and then on Monday, we'll have a lab where we get a chance to practice all of this ourselves. So we'll have, hey, do these couple things, right? Do these arithmetic operations, do these string operations, convert some stuff from text into characters, back and forth, just practicing a bunch of stuff like this, just doing your own practice. Or I'll say, hey, do this, and you have to go out and remember the right way to do the operations and that sort of thing. Again, we're starting a little bit slow, but that's okay. If you have previous programming experience, I apologize, you're probably bored. But if you've never programmed before, we're easing into it here. We're going little bit by little bit by little bit. So we got to learn to walk before we can run. Right, so we got to learn some of these basics, some of the operations, that sort of thing, the assignments. And then again, dealing with errors in Python can be really obnoxious. So like if you typo something, it has no idea what it is. It just says unresolved reference. It means it doesn't know. It doesn't match anything above. Okay? So if you'll find those errors, you'll run into them, those sorts of things. So like if you don't end a string here, it says missing closing quote. Look at that. It knew what it was missing here. It was missing a closing quote. So I'm going to add that single closing quote there. We should be happy. Or if you're missing like a parentheses, you get that little red line at the end. Let's see, where's my error? Hover. There we go. A comma or parentheses is expected. Right? You could comma separate the next value in print or the parenthesis to end it. So you run into lots of things like that. You just got to be careful. Like if you miss your operator, that sort of thing. This one's not helpful. Comma or parenthesis expected. Well, no, I meant to have an operator here, but it has no idea what I meant. So the errors aren't always perfect. They're not always going to give you everything, but they're just, it's trying here. All right, so I'm going to commit all of this to GitHub. Right, I'll see, hey, main changed, right? The red lines were removed, the green lines were added. So most of it's green here, right? But it saw, hey, these lines were removed. This is what's new at this line. Sure. And here's chapter 2 examples. I'm going to commit and push. All right, so all that will be out on github.com on the course repository. We should be in good shape. I'll post that quiz for chapter 1 today, and then I'll post the quiz for chapter 2 after we finish talking about chapter 2 on Thursday. And we'll go from there. So you'll get at least a week on this. Not too big of a deal. Thank you, Bendowie. I definitely have to sit up straight. Although if I sit up too straight, I bump my head. Gotta be careful. Or maybe I should just lower my chair. I'm used to slouching. Let me use my backboard here. I love this thing. I really should get a better chair. I've had this office chair for years. I just need to get a better one, but keep being lazy about it. All right, awesome. So should we send a raid off to someone else in Twitch land for fun? I should do that. That's always lots of fun. So we put on my ending screen here. And we'll go from there. Again, this is just part of the fun, just totally optional. No big deal. If you have any questions, thoughts, or concerns, then let me know. Happy to meet for office hours by appointment. We can go from there. Let's see who's around. Oh, we can check out Obother. He's lots of fun. He's what is he doing today? Uh-oh. His machine broke. He's got a really cool machine. If you subscribe to his channel, he has this all set up that'll go and like burn your name in with a laser. It said it's dead. So we'll go check that out. Take care, everybody.